Okay, everybody, welcome to Circumference Area and Volume Day 7. And on Day 7, we're going to cover surface areas and volumes of cones. Now, so far we've been doing volumes, which is the amount of inside space, but now we're going to be talking about surface area, which is kind of the amount of outside space. So if you think about the area of just like a flat square, where you're just finding like a flat surface area, that's what surface area is. So you're looking at the outside surface of some three-dimensional object and you're figuring out how much paper or how much like flat surface on the outside it would take to cover that object. So if we're looking at the definition here, it says surface area is the total area of the surfaces of a three-dimensional object. And then, for example, it says the surface area of a cube is the area of all six faces added together. So if we think about a cube here for a minute, I could draw an actual cube. And I apologize because I am not the best artist, but there's your cube. Now, if you're thinking about a cube that has six faces, it's got 1, 2, 3. One would be on the bottom, which is 4. One would be in the back, which is 5. And then one would be over here on this other side, which would be 6. Okay, so it has 6 faces. So what we do is we take the cube and we lay it out flat into this figure right here. And this is what we call a net. Okay, it's just when you take your three-dimensional object and lay it flat. Now, let's say on our cube that we had side lengths of 2 by 2 by 2, and I wanted to know the surface area of that cube. So really what you're looking at here is you're saying, okay, well this is 2 by 2. This is 2 by 2. All these have a side length of 2 because if we're considering a cube has all the same side lengths. So anyways, where I'm getting with this is if we take a look at the top square and it's 2 by 2, then this square right here would have an area of 4. Just like the one below it would have an area of 4, the one over here, they would all have an area of 4 because they all have side lengths of 2 by 2. So area of 4, area of 4, area of 4. So if I want the surface area of the cube, I would just add all of those together. So I would have 4 plus 4 plus 4 plus 4 plus 4 plus 4, which is 1, 2, 3, 4, 5, 6, because there's 6 sides. Easier way of doing that would be saying 4 times 6, which is 24. So the surface area of that particular cube would be 24 units squared. Now, that's an example doing a cube, but our focus here is we want to get to the surface area of a cone. Okay, so first of all, let's take a step back and remind ourselves what a cone is. So a cone has a circular base, okay, and then it goes up to a point at the top, which is called its vertex. Now, the two main things that we're going to be focusing on here is on your cone, you have a height, and you also have a slant height. Okay, now your height is typically going to be denoted with an H, versus your slant height you're going to find is going to be denoted with an L. Okay, so if I give you an L, I'm talking about the slant height, which is the one on the side. If I give you an H, I'm talking about the height, which is the one straight up the middle. Okay, now when you're finding surface area, the cone kind of has two surfaces. It has the surface on the bottom, which is its base, which is a circle. Okay, so you have to find the area of a circle. And then it also has like the cone part right here, which also has like a surface area that kind of goes like this. So we have to find the surface area of that part, which wraps, you have to think in a circle the entire way around. Okay, so it's not just that front part, it's also like the whole way around the back. So there's a way to get to that, but I'm just going to show it to you. So in order to find the surface area of a cone, this is our formula. So S is going to stand for surface area. Pi, once again, is your 3.14. R is going to be our radius. So the first part, pi r squared, is the area of a circle, which is the bottom part that we drew. That's your bottom part. Now your second part, because you have to add on that top part, is pi r L, and L is your slant height. Okay, and make sure you're using your slant height, not your straight height up the middle. And they kind of give you a picture over here. You want this one over here, not that one right there. You want the slant height. So surface area is pi r squared plus pi r L. Examples. Find the surface area of the cone. So surface area is pi r squared plus pi r L. So I'm just going to fill some things in here. Pi is 3.14. The radius on this particular picture, or this particular cone, is 5 squared plus pi times radius. Oh, I'm sorry, pi r squared plus pi r L. Backtrack. I wrote the same thing twice. So starting out again, we've got 3.14 times 5 squared plus 3.14 times pi L, and then L is your slant height. Now, if I'm looking at this particular picture, did they give us a slant height or did they give us a height? And the problem is they gave me a height right there. They did not give me a slant height, which is L. So we need to find that slant height. Okay, so let's take some notes down here. Find L. And the way we're going to find that is I'm going to look at what I outlined in blue there, and I'm going to notice that this is actually a right triangle. And on a right triangle, we have this thing. It's called the Pythagorean theorem, if you remember anything about that. And the Pythagorean theorem is a squared plus b squared equals c squared. Now, the most important thing here is you have to remember that the c squared is the hypotenuse of the triangle, which means it's the longest side. So if I'm looking at the blue triangle that I drew in the cone, you have a 5, you have a 12, and then you have a side that I labeled as L, and you're asking yourself, okay, well, which one is the longest side, or which one is the hypotenuse? And I hope you're thinking, well, that's the L. Okay, so this is your hypotenuse, which means the other two sides, the 5 and the 12, are going to be your A and B. And it doesn't matter which one you pick. 5 can be A, 12 can be A, it doesn't matter. Those two are interchangeable. But I'm going to substitute them in, and I'm going to do 5 squared plus 12 squared equals L squared. And then I'm going to start to simplify. So 5 squared, excuse me, is 25, plus 12 squared is 144 equals L squared. Then I'm going to take 25 plus 144, and I'm going to get 169 equals L squared. In order to get rid of a squared, I'm going to square root, and then I'm going to get the square root of 169, which is 13, equals L. So I'm going to come back to my picture. I'm going to get rid of the L. I'm going to put the 13, and the 13 is my slant height. So if I go back to my formula of pi r squared plus pi r L, you're going to want to substitute your 13 in for L. Now you're looking at this formula right there. And if you have a nice calculator or you have your phone, you can just substitute that all in at once. So let's see. 3.14 times 5 squared plus 3.14 times 5 times 13, and I'm coming up with 282 3.6 inches squared, and surface area is in squared units because we're talking about an area. Remember, perimeter is just inches, area is inches squared, and if we were talking about volume, then we would be doing inches cubed. So surface area is inches squared. Next one, find the surface area of the cone. So, same as before, surface area is pi r squared plus pi r L. And we're going to start by filling in what we know. So 3.14 times the radius squared plus 3.14 times the radius times the slant height. So on this one, I'm looking at it, and we're given 10. Is 10 the slant height? And the answer to that is yes. So because it's slant height, we can just substitute it in. We don't have to do any extra math, and we're good to go. So grab your calculator. 3.14 times 7.8 squared plus 3.14 times 7.8 times 10. And this time I'm getting 435.9576 meters squared. And if we don't want to worry about rounding, just leave all the decimals on there. But if this is a multiple choice test, just pick the one that is closest.